Okay, hello, welcome back to another one of my video log recording sessions where I talk about genetic algorithms. The date time is 2025 November 6th, so that's like how many days was it? The last video was recorded 9 days ago, give or take, or exactly 9 days. So, but despite the long interval, I'm afraid there isn't much I have. There isn't much I have found out. Nothing that new. Nothing astounding. But I decided. Well, like always, I decided to record it so that I don't forget in the future. So, in my last video, I remember saying that I need to do a couple of more grid searches for true chaotic and true chaotic dynamic genetic algorithm, which I did. I did that 4 times, so let's just start by writing that. Okay, true chaotic GA genetic algo and true chaotic dynamic genetic algo using varying values. Now by values I mean utility values and constraint values, and there. So that's what I did. Yes, and I did 4 rounds of grid searches, and I'll also write these down. Is there anything I could just refer to? Oh no. Oh, actually, this is a lot better. Oops. There. And the ones I did are these. Let's make these bigger so that I can, yeah, I hope this is readable. So here we go. This one, and now I'm going to explain the specifications of each of these grid searches. So this one uses varying. Why do I always do this? This one uses give me 20, and this one uses varying. How many times am I saying that? Varying utility values and also varying constraint values. And this one, the number of items is fixed at 100. Now, whereas this one is almost the same, except that it only uses varying constraint values. I'll explain why. And the same could be said for the last two of these. However, in this case, the number of items is initially 10. Let's zoom in. Initially 10. Starts with 10. And you know what? Let's do this. 10. Starts with 10, 20, 30, all the way to 100. And same for population size as well. So the same could be said for this as well. And also, well. And this also equals pop size as well. Same here and same here. Okay. Just 1 second. Ow. And the purpose really? Okay. The purpose of this, the purpose. No. The purpose was to introduce more randomness in otherwise what is pretty much fixed. More randomness in the evolution and progress, so that everything evolves whilst keeping some of the diversity through randomness. And this time all the randomness would be coming, all the additional randomness would be coming from all the varying things, varying values. Okay, so so this first one could be called true chaotic, or rather it is true chaotic. The second one the first one is true chaotic, so is the second one. The third and the fourth one is true chaotic dynamic, all GA, as in genetic algorithm. So again, coming back to the purpose is to introduce more randomness in evolution, so as to encourage progress. I don't know how to spell progress. It looks like it. Progress and a certain degree of diversity. And let's see what happened. So this is first of all, this is grid. Oh my god, GRS as in grid search, and 2025 October 29th, the 0th one, using the ReLU-like method for choosing the entities to learn from. Yep. So when we have a look at the first one, which is this one, maximum errors. This is exactly when I realized that something was wrong. And here we'll see why. So, if we look at the maximum errors per entity event ratio group, per entity event ratio, we see that the maximum errors or maximum errors are not what they used to be. There's something off about them. There's something different about them, all of them. Because the ones before looked like this. They all ended in zeros or fives. Okay? 0, 0, 0, 5, 0, 0, whatever. And that's because the utility values were set up that way. But in this case, in the case of true chaotic genetic algorithm using varying utility values and using varying constraint values, varying utility values and varying constraints, well, because each value of an item used to be fixed. At a certain value there. Maybe we'll call that x. But now that I set each value to vary, to be different, by making it follow a certain distribution, something like a normal-ish distribution, they're not going to have the same value every time. And when this happens, or when an entity is evaluated, when in terms of some utility value, or when an entity assesses itself by summing up the constraint values of all the genes that it has accumulated or switched on or activated, the values will be picked from here, 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 or here, here, whatever, anywhere within this curve. So what that does is this. So that's why we have all these values with different last digits. So by plotting all these maximum errors per entity event ratio, I won't be able to decipher which event ratio produced the true ceiling, which is 2865. So that's when I realized that it may be not so wise to set both the utility values and the constraint values to be different all the time, to be varying all the time. So it's not so wise. So once I did that, once I realized that, I had to move on to only, well, I had to set the constraint value, only the constraint values to be changing all the time. Of course, still following a certain normal-ish looking distribution. So that's what I did. And that is the second one, which is this GRS 2025-10. This is 29, as in 29th, first ReLU, where the number of items and the population size, max population size, is set to 100, and only the constraint values are to be varying, to be different all the time. And the way that this is carried out is that all the constraint values, when an entity is summing up its constraint values and kind of deciding either willingly or unwillingly to strike itself out, it will carry that distribution information, or it will generate that distribution information within that process. So every entity that is out there doing something will be creating their own distribution and sampling from that distribution independently from one another. So that's how this is done. This is done in the entity process. So when I do that, notice the difference in how the numbers look in the maximum errors. Compare this to this, and as you can see here, we have for now we can just ignore the true ceilings here because there's another problem, but just have a look at how the numbers look different. See, they all end in some weird last digits in the ones, but here everything is either a 0 or 5, just right before the decimal point. So that's what happened. However, the absence of the red vertical line in this plot on the left does not mean, and did not mean, that no true ceilings were achieved. And the presence of these red vertical lines on the right does not necessarily mean that real true ceilings, there could have been, does not necessarily mean that true ceilings were actually achieved, because all of these, or some of these true ceilings could have been false ones. And the reason for that is that since the constraint values are varying, since the constraint values are fluctuating, rather, let's say, at some point if an entity chooses to downplay some of its rather crucial constraint values, it will not be struck out. It will not be struck out. It will just avoid being struck out. And if the other way is also true, is also possible. If an entity, whilst in all the possible combinations of its summed constraint values, if that entity somehow, for some reason, chooses to, overplay some of the very crucial constraint values, as opposed to what the summed constraint value would have been had it not been for the varying constraint values, this entity would have been struck out, because it way overestimated or overpaid, I think is the right word, overpaid for the constraint values for all the genes that were activated in the entity. So if we consider that, the true ceiling that is supposed to, or that is allegedly present in these plots may actually be over the threshold, over the maximum constraint, that which was 18,000. And we've established more than enough that if we allow, or rather, if the summed constraint value, if the summed constraint is over 18,000, over the maximum constraint, if the summed constraint value of an entity is over the maximum constraint, it is very easy for that entity to reach and go above the true ceiling. Which is why I think in some places, like right here, we have 2870. This isn't supposed to happen. This is impossible. But we have it anyway. And hold on. Let me just so that 2870 is impossible. That happened once, and I think maybe even once or twice more, maybe. No, maybe not, but that happened. So, so another process had to be introduced. But before moving on to explaining that, the thing is, I think this is something that I'm thinking about right now, and I'll be trying to. The reason I'm doing this is that I want to justify myself for allowing these certain values, namely constraint values in this case, and possibly utility values in the future as well. But anyway, allowing for these values to fluctuate, to vary at certain points in time, or at many points in time, and it just hit me. It just now that if it goes above, oh my god, if an entity exists, if there's an entity, and if the summed some constraint value, or there's an entity or more than one entity, goes above the maximum constraint, if we allow this, or rather, if the maximum constraint is set to 18,000, alright? But because we yeah, if we actually change the value for the maximum constraint, for example, set it to 18,500, and then it would be a lot easier to come up with entities that have a some utility value of 2865. At the same time, some of these chromosomes would exceed 18,000 because the higher maximum constraint was 18,500. So to me, allowing or shifting the bar, or changing the goalpost, or shifting the bar, raising the bar for maximum constraint, feels like cheating. Where's my mouse? This whole thing just feels like cheating. I mean, there is no right or wrong answer. There might not be, but is it cheating? However, allowing the values to vary, utility values and constraint values, while they allowing them to fluctuate, given some distributions for different values of different magnitude, doesn't feel that much like cheating. Is this cheating? I mean, this might sound like cheating, but it does sound like, to a lesser extent, this sounds less like cheating than actually adjusting the maximum constraint, where the actual desired maximum constraint originally configured was 18,000, but in order to get more true ceilings, we raise it by just a bit, like 500 or 1,000, so it could be 18,500 or 19,000. But this is just directly messing with the maximum constraint, and therefore feels more like cheating. However, using the method or methods where the utility values and the constraint values just fluctuate. They oscillate and fluctuate, and they vary over time, every time or some other time. This doesn't feel like cheating, or less like cheating. So that's why I did this. And I think, in fairness, in the future, I think this is more valid, or this will be more useful, because in the next steps, or in future plans, in my future plans, I still intend to have all the hyperparameters fluctuate, change all the time, change constantly, or somewhat intermittently, or constantly, or whatever, just subject to change. Hyperparameters will be subject to change whilst whilst a process is going on, whilst the whole evolution cycle or process goes on, so that it never ends, or until at least until the evolution process is deemed or considered complete. So I went through all the entities that were created during these these 4 grid search attempts, and I went through them and I filtered all the unique true sealing chromosomes, and this is what I got. So from GRS 2025 1029 underscore 0 underscore relu, whoops, just one sec. So from the first grid search attempt, I got 7 unique true sealing chromosomes, and this, which if you remember, both the utility values and constraint values were varying. From the second one, where only the constraint value was varying. Oh my god. Yes. Let me just write VARCSTRNT. I got 13 unique true sealing chromosomes. And for the true chaotic dynamic, where both of them had constraint values, it's varying, CSTRNT, I got 0 true sealing chromosomes. So, which, to be honest, is a disappointment, because the purpose, again, of this whole thing, of this experiment, was to introduce more randomness in evolution, keep progress or evolution and diversity, so that even when we have only 100 entities whilst doing true chaotic dynamic, and 100 entities in 100 libs, I could reach true ceiling. And the reason I wanted diversity was that diversity promotes a wider. This is I would actually be repeating myself, but I think I still need to say it. Diversity actually promotes a wider variety or a wider range of different or unique chromosomes that may or may not evolve closer and closer and eventually reach the true ceiling. And as demonstrated whilst doing pseudo chaotic, 400 entities was about the minimum entity count. But since I can't have 400 entities right now, I wanted to find a way. I wanted to find a way to produce. I wanted to find a way to be able to produce true ceiling entities and true ceiling chromosomes whilst given these conditions, which I still failed. And I'll show you some errors. These are the results of maximum errors, and usually the value, just the maximum error of every entity event ratio comes close to 2800 or slightly below 2800. See, there's a 2800. However, there is 2785, 2760, 2785 again. Come down here, we have 2815, which is quite high compared to the other 27 somethings, and 2795, 2790, 2790, 85, 2760, 2805, that's high, 2810, 2810, yeah, 2815, 2820, that's also high, and 2815, still quite high. But notice how when the maximum ever of a sum utility value is high, the MOP ratio was 10 for mutate, 34 for learn, and 6 for procreate, and 50 for chill. MLPC, but leave out the C, as in leave out the chill. But anyway, so the learn rate is actually 3 times as high. So this means that the distribution, the entity distribution is very likely to be converged, is very likely to be narrow shaped. 2800, and here even at least in this case, the M and L, the ratios for mutation and learning, is kind of similar, kind of close, kind of not equal per se, but kind of close. And here 2820 we go down, and then it's 1135 and 4, so that's still 3 times higher. And 2815 here, 25, 31, 4, and 14. So, and here as well, 2810, 24, 30, 6, 40. So because the where is it? Nope. Because we only have 100 entities we give all the entities 100 blips in which they could exist. There is MLP and then in brackets C. Because we only have 100 entities, we need the entities to learn more than mutate when it comes to these two things. But the downside of that is that if there are no entities that have the potential of going above 2800, if there are no or if only a handful of entities who are capable of doing this, this will not happen. Because everyone's learning from entities that are close to 2750 or 60. They're just, the diversity level isn't just high enough. But once that does happen, when there are entities who show promising potential, the other entities just quickly pick up on it, because entities are twice as more likely to learn than mutate. Which is why the maximum ever scores go down, there's a downward slope towards the end towards the right, as the mutate event ratio gets higher than the learn event ratio. Again, I have to note that learn event ratio is not the same as learn rate that I used to talk about a few months ago, but I know it's all my fault, confusing terminology. In this case, this is the weird one. This is the odd one out. It's 43, 34, 3 and 20, so mutate is higher than learn, and yet we still reached 2805, but that's the odd one out. That doesn't usually happen. In other cases, if the mutate event ratio is high or higher, the maximum ever will start going down. The right half is lower than the left half. Usually the right end is supposed to be lower than the left end. That's obvious because here the very right end usually has, or the very right ends always have 0 for the learn event ratio, whereas the left ends always have 1 for the mutate event ratio. And the lowest for the mutate event ratio was set to 1 because without it being 1 or above, there is no progress at all, because all the evolutions and all the entities, all the initial entities are actually void entities, or they all carry void chromosomes. So that's why it has to be set to 1. But the lowest event ratio for learn is 0. So yeah. That's what happened. Oh yeah, one thing that I also need to mention, I also need to point out, is that it is quite likely, and why did I just zoom in too much? It is quite likely that what color should I use? Just use black. If you look here, when we used varying constraint values only, this gave us 13 unique true ceiling chromosomes. And when we compare that to the 3 we got from one of the other grid search results that I think I covered in my second last video, this is where all the values were fixed values, and I got 3. And in the other one, in the one after that, named 20 GRS 2025 1002 underscore 0 underscore relu, I got 3. And then GRS 2025 1002 underscore 1 underscore relu, I got 1. So, which is why last time I think I said somewhere, there we go, 4 out of 480. But here, in the very first go, I got 13. So it may be fair for me to claim that using varying constraints and also when both the values were varying, I got 7. So 7 I think is still higher than 3. So when using varying constraint values might be better than using varying constraint values and varying utility values, and this might still be better than using fixed values when it comes to doing true chaotic. Of course, I also remember that using varying values or still kind of categorized by me as being dynamic. So I'm just going to slightly ignore the fact that I said it in that context, because I'll be just trying to clarify myself. When doing true chaotic genetic algorithm with the number of items fixed, when the number of items is fixed and therefore the population size is also fixed, this holds. This whole thing is likely to be true. Sorry, I have to catch a fly there. I didn't clap for no reason. Of course, when doing, if we were to do pseudo chaotic, this wouldn't actually matter, because pseudo chaotic just outperforms true chaotic, at least till now, at least up until, at least so far. but I think the true chaotic way has its own purpose. But anyway, and also when it comes to diversity, which is very important, so as to lower the risk of entities going extinct. When it comes to diversity, dynamic, as in varying values, as in using varying values, is better, is encouraged when as opposed to static. Now, this is probably the first time that I use the word static. Static as in non-varying. Well, actually, non-varying means fixed, so fixed values. But which quite obviously, or this may not be true, but I'm guessing it is very likely to be true when it comes to convergence, as in the spread of entities, or lack thereof. Dynamic is worse than static. Yeah. But even when given all this, even when the constraint values are always somewhat oscillating or fluctuating, and some entities might be downplaying or overplaying and end up overpaying for the constraint values, overpaying for the price. It's quite important for me, very important for me to mention that when I filtered all the entities, the filter, or rather the filtering, was done with fixed values. So in these what I claim to be unique true ceilings, they all qualified, as in they were all 2865 when it comes to summed utility values, and they were 18,000 or lower when it comes to max constraint. When it comes to summed constraint. And so far, with all the things that I've done, reminds me of that song by The Killers. All the things that I've done. So I have 414 true ceiling chromosomes. So, but that's still a very minute amount, since it's still 414 over 2 to the power of 100, which this is like 30 zeros. 30 times 30 zeros plus a 1. I think it's like 1.2 times 30 zeros. So, which is still a very minute amount. And all I'm doing for the past, or what I'm doing for the past 3 to 4 months, is trying to find a way that would, trying to find a way that is likely to guarantee a robust distribution whilst robust entity distribution whilst steadily or providing unique true ceilings. More than one unique true ceiling. So that's what I want. And so far it hasn't been that successful, I must admit. But I might have to move on now. Unless I find a way to increase this number, that is 100, all the way to 400. And by the way, the time taken for each of these entity event ratios and entity event ratios combination and the data point counts were all kind of similar, so I don't think I need to talk about that. They were similar in their own whether it is varying utility values and constraint values or fixed utility values and constraint values, the time it takes is almost always kind of the same. It's approximately the same. So that's that. I don't hold on. So I think that's all I have prepared for today. I still don't have an idea, or at least I still don't have just that one idea that I feel that I need to cover and research and talk about in my next video or for my next video. But because I have so many questions now, and that's even worse. So yeah. Again, the question always is, now what? Huh? Now what? Okay. Anyway, thanks for listening. Hopefully see you next time. Bye.